All right, today we're going to be learning about domain and range and how it relates to graphs, functions, and coordinates that we're going to be using for linear functions, quadratic functions, all throughout the year in algebra. All right, so first off I want to just talk about the terms, domain and range. This first one, domain. And just as a reminder, as we're going through these, making sure you guys are taking good notes so you have it as a study guide later. All right, so for domain, the domain is the set of all x values. And as you know, for an ordered pair, a point on a graph, you're dealing with an x comma y. I want you to get that down because we're going to use that definition to help us identify domain and range throughout. So for domain, which is the set of all x values, what do you think the range is going to be? It is the set of all y values. All right, so let's look at it in a couple different ways. First off, we're going to look at it from a relation of points, a set of points. So a relation would be represented as ordered pairs. And I'm going to use 5, 7, negative 2, 3, and 0, 4. These are my 3 points. All right, so now, as I'm looking at the domain, which is a set of all x values, as I look in this relation, I'm looking to identify each x value that is contained in that relation. So the way I would represent that would be the domain, and I'm going to use that as D. Then use a colon, and 5, negative 2, and 0 are my 3 x values that are contained in that relation. For the range, seven, 3, and 4. This is one way we're going to ask you to identify domain and range. But as we get more advanced, we're going to start taking it not just from ordered pairs, but recognizing it on the XY chart. So here it's shown in a different way. I still have 3 points, but it's represented on the graph. I've got negative 3, 3, negative 1, 1, and 5, 2. So let's identify the domain and range for these. Okay, domain is the set of all x values. What are my x values? Negative 3, negative 1, and 5. Negative 3, negative 1, and 5. And the range, 3, 1, and 2. Nice. Again, a relation, which is a set of points. Graph, set of points as well, but represented on the XY chart. All right, so next piece which we're going to get into, which is a little bit more advanced, but you're going to get very comfortable with that, just knowing domain is a set of x's and range is a set of all y's. So we're going to look at a function. And we're going to start off with the function y equals 1/2 x minus 2. So just a little bit of a review. Y-intercept of negative 2, I go up 1 over 2. Okay, now, as I look at this graph, I need to look and think of all of the points that are contained on the function. I notice that it is an infinite amount of points. So if I wanted to represent this function with points, I would have 0, negative 2, decimals in between 0 and negative 1, going to positive infinity and going to negative infinity. So if I wrote out every single ordered pair here, I would recognize that every single x value is represented. That for my domain, the way we're going to represent that is with this symbol, and this symbol represents all real numbers. Okay, so with all real numbers, every x value is going to have a corresponding y. Another way to think about that is if I pick 0. If I plug in 0, I'm going to get a y. I could pick -1,000,000. I'm still going to get a corresponding y that falls on this graph. So now let's look at our range, which is a set of y values. So for the set of y values, I'm looking at, okay, what y values are going to be contained. I'm looking on that y-axis and recognize at any point here, I notice there's a point on the graph. Here, there's going to be a point on the graph. Positive 300, I'm going to know because that's going to carry off into that first quadrant to positive infinity. And same thing goes with going to negative infinity. So my range is going to be all reals as well. Okay, now let's look at it in a different light. We're going to be getting into a function which is the absolute value function. And the way this graphs is it looks something like this. Don't get too concerned about what the graph's going to look like. Right now I want you to think about domain and range. What are some things that we know about absolute values? The absolute value of 2 is 2. The absolute value of -3 is 3. The absolute value of -5 is 5. What do we know about the absolute value of any number? What's it always going to be? If you said it's always going to be positive, you're correct. So for you, if you are plugging in values for x, our y value is only going to be positive, and it's represented here. So for this, I'm looking at, okay, I notice my x values, I can put in anything for x. So my domain for this is going to be all reals. Because can you think of anything I can put in here that's not going to yield an answer? No. I can pick 3, I can pick 100, I can pick -1 trillion if I want. I'm still going to get a positive y. Now as I look at the range though, there are limitations. The graph represents that as a visual, knowing, all right, 0 is represented on the y-axis, plus 1 and 2 and 3, and all the way up to positive infinity. But recognize there are no points on the graph that have y values that are negative. So in this situation, we're going to use an inequality, y. And that's, again, how I'm going to represent that. Our range is for all y's that are going to be greater than or equal to 0. All of my y values equal to 0 and greater than. As we delve further into this, you make sure you get comfortable with understanding domain is all the set of x values and the range is the set of all y values.